I am 15 years old.
Oh, see, you're not the only one,
Also, I
kid.
did my makeup and I look pretty darn cute. So I'm like,
Yeah, you do. Oh my gosh. Frankie's a cutie pie.
hello,
I
that's
don't
me.
I don't even know what makeup is.
Oh, I can't makeup. Are you kidding me? I like it's like the first time I've done my makeup in like
Me and makeup, we're not friends.
I'm a cutie boys. I'm single. No, I'm just kidding. No, 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 I'm kidding.
You probably act more mature than me. We're talking about Frankie, right? No, I'm just kidding. Just kidding. Just kidding. I tease. I tease. I love my class. You guys are the best. And this baby. Look at this baby. She's out. She is out. Good job, babysitter Lizzie. Oh, she gave me a fist bump. Yeah. All right. So this is what we're kind of working with this week. Last week it was translations and reflections. And this week we're going to talk about rotations, lines of symmetry, dilations. We'll get to a little bit of tessellations, but yeah, that's what we have this week. Does anybody have questions about last week? Anything specifically that wasn't making sense? I know Beth is good. Okay, we'll do it this way. If you have a question, go ahead and ask it. Anything that doesn't work or anything like that. I'm sorry. I'm so sorry. Tessellations isn't on your to-do list. That's probably an error. There was an error that I did last week with not having it ready, so I'll take a look at that. That's weird. Okay, well, don't worry about it. I'll take a look at it. If it shows up next week, it's not a big deal. I'll fix it. If it just shows up next week, I'll just leave it for next week. It's fine. So we don't need to add more, right? You guys got enough on your plate. Okay, so we're going to talk about, we're not really even going to talk about it anyway, but yeah, lines of symmetry, rotations, dilations. Hey, knowing you, you probably took your notes ahead of time, my friend. So, yeah, can you guys see my Zoom group chat? I'm just curious what's showing up there. I only have one screen right now. There we go. Oh, great. Okay, good. I just want to make sure it's not in the way because it's slightly in the way for me, but I need it so I can see what's going on. Okay, so first thing we're going to talk about is lines of symmetry. Lines of symmetry are lines that can be drawn through some geometric figures such that one side of the figure is a reflection of the other side. So it looks like the figure got folded in half, basically. So you're going to be asked questions like about how many lines of symmetry certain figures have. And when you do that, you just got to make sure that um, oops, hold on. Okay, you just got to make sure that it's a reflection of the other side. So you can kind of see different figures here. We have like a letter A, a heart, potentially another figure. Nope, just the letter A and a heart. Triangle. You know, that is what? Oh, I'm sorry, baby. She poked herself. No, that's a really good example. And you know what? I thought of this, and I'll show you guys. People have said that Tom Cruise's face bothers them because his tooth is in the middle of his line of symmetry. I gotta show you guys. Have you ever seen that? It's like the weirdest thing, but I gotta show you. Okay. I'm gonna type in Tom Cruise symmetric face. Hopefully nothing naughty pops up. Tom Cruise. Let's see if it popped up. There we go. Watch this. It's really cool. But they talk about him because specifically beauty is defined by how symmetric you are. This guy, look at this. In his symmetry, his teeth are not symmetrical. Isn't that weird? Yeah, that's bizarre. See? It's crazy. Isn't that weird? You're never going to unsee that. No, it's just neat. It's just interesting how, everything is symmetrical except for that. I know, I noticed that. It's interesting. Oh, yes, I love you. Okay, I need my hand. Okay. It's just interesting. It makes me think of the symmetry that we're talking about. Right. Well, it's just interesting how his is. It doesn't look like super crooked teeth or anything like that. It just looks like it's off symmetry wise. That's why it's interesting. It fits into our discussion today because we're talking about symmetry. So, yeah, we've got different figures with symmetry. Just keep in mind, figures like squares and rectangles, they're going to have, rectangles won't have as many as squares, but you can have lines of symmetry on the diagonal. Because if we fold this side over to this side, it would be a reflection. So just remember that some figures are going to have multiple lines of symmetry, depending on what the figure is. So like an equilateral triangle would definitely have more lines of symmetry than just one. Okay, so speaking of that, take a look at these. Go ahead and draw in if you think these figures have additional lines of symmetry.
2, 3, 4, 5, 6.
Yeah, Lizzie's counting.
1, 2, 3, 4, 5, 6, 7.
What do you guys
8,
think?
9,
Yeah, I'm definitely thinking that first one. And remember, with your tools, you have lines, like perfect lines that you can draw. Definitely. Yeah, we got to visualize it like you could fold it over. So like here, you could definitely fold that over. I like how you guys are looking at it. Yeah, good. What about the triangle?
I
Yeah.
thought you could, but I don't. Never mind.
Yeah, no, it looks, it's just got to match up when you fold it over. That's it. What about that weird arrow thing? Are there any more there? No, I agree with you, Allie. Nope. And Casey. Good. So you guys got, when you put in lines of symmetry, it's got to match up with that other side. Oh, I can. Oh, did I just switch it? I didn't mean to. Okay. Hi, Nala. Look, there's Nala. Do you see Nala? Okay, so now we're going to talk about rotations. Yeah, I'm just checking. Rotations rotate the object around a given point. It does not change the size or the shape, but it does change the orientation. Rotations. Oh, yeah. Oh, they're not going to be hard. Oh my gosh. Evelyn's asleep with her mouth open. She's like this. It's really cute. Yeah. Very good. We'll get it, don't worry. But big thing with rotations is it simply rotates an object about a given point.
I don't like that.
Well, what do you want to watch?
I watch one.
Umizoomi, okay. Gotta watch the Umizoomi. And then Kaden, the video for, and then whoever might have missed it, the video for last week is up on Moodle. So, what's a good show? I'm sick of Umizoomi. Oh yeah, she loves Umizoomi. Umizoomi. Beth says she likes Umizoomi too. Little Big Awesome. Is that a show? It's called Little Big Awesome?
Mama, I want the movie. Mama, I want Umizoomi movie.
I don't think there is a movie, honey.
No, Umizoomi movie.
Oh, Movie Madness. I get it. Okay. It's the episode. Okay. So now I want you guys, remember, orientation is the only thing that changes here. It does not change size or shape. So go ahead and circle all or mark all of the rotations. What are all of our rotations here? You know, and that raises a really good question about reflections, because reflections, it's a flip, right? But it's not rotating it about a certain point. Like there wouldn't be a way, and I'm glad that you did that though, whoever did that, because this is an orientation change. You're totally right, but it's a flip. We want a rotation, and you guys are right. You picked all of the rotations. It wouldn't even pick a slide because that's just a translation. So good. Those are all the rotations. Changes it about a point. Okay, so remember, here are the money things that you want. So you're going to be told in Math Excel to make a rotation about a certain point. Okay, so you're going to be given a point, and they'll say, what does it look like after a 90-degree counterclockwise rotation? This is the chart that you want, because all that you have to do is flip around those points. Tells you to take your original points, flip the x and the y, and then make the y negative. So if we had the point 2, 4, if I want to do a 90-degree counterclockwise, so against the clock, so if you think of a clock, I have to draw this out because I always get confused. Clocks go this way, so counterclockwise would be this way. So a 90-degree counterclockwise rotation, I'm going to flip x and y and then make y negative. So flip it and then make the y, the original y, negative. So flip it and make what was y negative. So now we're at -4, 2. Right there. Or if I did 270 degrees clockwise, remember, if you think of a coordinate grid, every 90 degree is like a quadrant. So quadrant 1 is a 90 degree. This one is 180. This would be 270. So you just keep adding 90 every time. So clockwise, 270 degrees would be this way, and you would get the same point. If I wanted to do 180 degrees in either direction, all I do is I make my x and y negative. So instead of 2, 4, I would have -2, -4. So -2, -4, right here. This would be 180 degrees. And then if I wanted to do a 90-degree clockwise, I flip x and y and then make my x negative. What was my x? So I flip them And the 2 was my x, so that's now negative. So you're just kind of literally doing what it says on this chart. That's how you get those rotation points. Does that make sense, guys? Oh my gosh, great question. I would probably say infinite. Infinite, because if you think of it, you could divide it and divide it again. Yeah, that's a good question. Infinite lines of symmetry. My sister's gonna be, I had more hair in my mouth. I'm sorry. Stinking cat. My sister's gonna be so excited that baby fell asleep. She was so worried. She's like, I know you have a class. Good baby. Okay. When you are done, please raise your hand. Because I know there's a lot of good stuff to write down here. I would even put little examples here. So like if you have, good girl Lizzie, eat that oatmeal. I almost said yogurt. She does not have yogurt. I would even put like 2, 4 becomes negative 4, 2. You know, little examples in there. It helps. Take notes, take notes, take notes. That's all I can say there. Hello, whoever joined us.
Hi. Sorry I'm late.
No, no problem, no problem. Go ahead and write this down, this slide down real quick.
I was cleaning the bathroom, so.
Oh yeah, it's important to do.
Who's that?
This is my beautiful new niece. Her name is Evelyn, and she is such a good baby. She fell asleep. Okay, Allie, go ahead and watch the rest of it on Moodle. I will post it.
I'm gonna zoom out and then or exit full screen and then snapshot it.
Oh, go ahead. My daughter's eating her oatmeal. This is a weirdly good day. Usually it's not going that well. I was a little worried, but it's going good. Yay. Okay, remember when you're done with this slide, raise your hand, please, so I know we can move on then.
What live session week is this?
This is week 16.
Holy cow.
I know, it's crazy. I know, Tyler, it's just bizarre. I'm not used to this. Something's gonna happen, something big. I hope not.
Okay, back to full screen. My niece just turned 1 on the 9th of this month.
Oh, cool.
And then my oldest niece turned a whopping 11 years old on the 7th.
Yeah, my son's 11. He's gonna be 12. What?
I'm gonna be 17.
Wow.
In a few months.
Happy early birthday. You're a summer baby, huh?
No, I was born in September.
Fall baby. Gotcha.
Yeah.
Okay, so are we all good for the next slide? I see many hands are raised.
I'm good to go. I just forgot to raise my hand.
Hannah, Kaden, Jana, what about you guys? Oh, Jana had his hand up, sorry.
You want to know something else exciting, Jen?
What?
Do you hear any noise in the background?
No.
They're all outside.
You're probably like, sweet relief.
Yeah.
Yeah.
Because of all the rainy days, they've been locked in the house for like forever. So they were getting all hyper.
So today is an outside day, right?
Yeah, yesterday was too. And yesterday I thought it was going to rain because I saw this big, really, really big cloud.
Yeah. You were like dreading it.
It didn't rain.
That's good. Okay. So what we're going to do is we need to rotate this image 90 degrees counterclockwise. So we're going to, and you guys can lower your hands because I'll use it again, definitely, but 90 degrees counterclockwise. So according to the rule, that is right here. We're going to flip X and Y and then make what was Y a negative. So what we're going to want to do is we're going to first list all of the points. Yeah, we're not going to draw it on there yet. Nope, let's not do that. So let's go ahead and list what the points are. So first, what are the vertices of triangle TSN? What do you guys think? Which one? Number 1 or number 2? And we're not worrying about number 3. What are the vertices there? Which one's right? -1, 1.
I think it's number 1.
Number 1? Okay, so let's see. You guys are saying 1? Yeah, I would check just by the first point. Remember, first point is X, second point is Y. So I would go -1, 1. That's definitely T. And then this one is the reverse, so it's not going to be that one. So now let's list the new points. Right? That's usually how it works. It's the one you misread. I tell you. Okay, so someone raise your hand and tell me what would be... No, Tyler, we're just reading the points. You can do it. Oh my gosh, baby's making me warm. Whew. She's so warm and snuggly. Okay, so what would be, someone raise your hand and tell me, if I do the rotation 90 degrees counterclockwise, what would I end up with for T prime? Someone raise your hand and tell me. Because remember, according to the rule, I switch X and Y, and then I make what was Y negative. Let's see. Got so many menus to move around. Miss Stella, what do you think it would be? Oh, no, that's okay. Casey, what do you think?
I'll be right back. My Alexa is going off, so I gotta go deal with that.
Oh, no problem. That Alexa, I tell ya. Okay.
Alexa, play Despacito.
I'll be right back.
Sorry, that was really random. Okay.
Alexa, play Despacito.
Oh.
You made my Alexa play it.
I'm not even.
Okay, what just happened?
Stop.
Oh my gosh.
Did it really do that?
I'm not even kidding. You turned it on. I'm
Alexa,
not even kidding. It's literally playing this.
Alexa, play Despacito.
Oh, that's really funny. That's really funny. Sorry.
It's literally playing.
You tried doing that on mine, Frankie, and it didn't work.
Alexa, stop.
That's really funny.
Gosh.
Despacito.
I have my own Alexa.
It's such a creepy song. Do you know what the lyrics mean?
It's a bop, honey. Oh yeah, I know the lyrics.
Yeah,
It's a bop.
it's
Yeah.
a bop, but it's really creepy.
It's a creepy song. Yeah, it totally is. When you look at what the words mean. I like the Spanish version better. Go with Justin Bieber. Sorry, no way. Biebs, you ruined it.
I don't like Justin Bieber for some reason.
Neither do I. He's just got that personality that you're like, no. Okay. Anyway, let's focus on what we're doing here so that we're not here longer than we need to be. So first thing we would do, what Casey did. Casey said it would be -1, -1. So that means she flipped X and Y, which would be 1, -1, and then made that new X negative. So that's right. Very good. So it'd be -1, -1. There's T. Whoa, you okay there? You're all right? And that would
Are
be
you
T
in a new house?
prime. I am in my new apartment. Yeah.
Oh,
Yeah, we moved.
last week's live session, you were in the same place, I think.
Oh, I was at my desk. I'm sitting on the couch today so I can hold
Oh,
baby easier. So, yeah. It worked out well. Hopefully it'll happen every Wednesday just like this.
Jen,
Okay.
this is completely off topic, but I learned how to do backwards mid spirals, shoot the ducks, and lunges in skating.
Nice. Very good. That's awesome.
And the people that were in my group and that were watching said I did really good.
That's awesome. Very good. Now I'm going to table our...
I'm going to mute now so I don't wake the baby.
No problem. I have headphones on. She can't hear. She's good. So what about S prime? What would that be now? If I flip X and Y and then make the new X, what used to be Y, negative, or opposite of whatever it was. So if it was negative, it would turn positive. What do you guys think? Raise your hand. Raise your hand. Raise your hand. Miriam, what do you think? What would it be? What would it be? What would it be? I feel like singing today because I'm holding a baby. -4, -1, Miriam says. That would be if you flip X and Y. So we got to flip it. And then we're going to do, so we got to flip it. What you were thinking is you just turned X positive. So now, Miriam, with it flipped, yeah, it can be really confusing. There are so many rules. I would do it one at a time. First do the flip, then now we got to make what used to be Y, which is now in the X spot, we got to make that the opposite. So what would it turn into, Miriam? If that's after it flipped, now we got to take that new X and make it opposite of what it is. It would be 1, 4. It would be 1, 4. Yeah, because the way you did it is just not flipping. That's all. So yeah. So first we flip the places where they are, and then take what's in that new front spot and do the opposite. So it'd be 1, 4. Good. Very good. So easy to confuse this stuff. So this would be, what did we just do? S prime. Now we got to do that N, that 1, -4. 1, -4. So what would that look like if I first flip it and then take the new Toru? That's a good name, Toru. What do you guys think? What would that be? First, let's flip it. What would N look like if we flipped X and Y? Someone raise your hand. Raise your hand. 2 participants. What? Doesn't tell me who. Okay, Dallas, what would it look like if you flipped it? What do you think? Oh, she's got the skater memes there. Or emojis. What do you think, Dallas? 1, -4. That's what it is now. That's what, and we're doing this point N here. What would that look like if you flipped X and Y? So make them switch position. Yes. The negative goes with the number. You actually have what it would turn out to be, which is good. But, no, never mind. Scratch, I said that. What you did is you flipped the signs. We want to flip the actual numbers. So we would have -4, 1 if you flip the numbers. When I say flip the numbers, I mean change positions there. So now we got to take what's in that new X spot and do the opposite of what it is. So what would that look like, Dallas? What do you think? If I take what's in that X spot and make it the opposite. Yeah, but the Y stays the same. So the Y is a positive. You only do the opposite of that X, not both of them. I know, it's confusing. I got it. Totally. So we're only going to do the opposite of that X. We don't care about what the new Y is. We leave that how it is. So now we're at 4, 1. There is our new triangle. Like this. So that is a rotation 90 degrees counterclockwise. Any questions on that? Questions? Okay. If you come up with a question, go ahead and ask it. Because now we are going to talk about dilations. A dilation makes an image bigger or smaller. It does not change the shape of the object, but it enlarges it or reduces it. The amount that an object is enlarged or reduced is called the scale factor. So it's kind of like what we were doing with scale before, but now we're just doing it to one figure. Now we're worried about the actual change of the figure. So it's very similar math that you would use. Oh no, baby is waking. Wake up, baby. Have your nana. Yeah, have your nana. She's waking. That's okay. Okay, so go ahead and circle what you think are dilations. Which ones are just size changes of an object, bigger or smaller? Yep. Oh. Hi, baby. You want to fall asleep again. Yes, you do. There you go. Good. There's actually one more that I spot. It's kind of sneaky. Yeah, very good. Very good, we say. What? I think she's done with her nap. That's your middle name is Dan. Oh, I like that. She's a good baby. She just needed a little power nap. Did you get tired? She's staring at my headphones. She's like, what kind of a zombie are you? I don't know why zombie. Robot, that's what I'd be. Okay, so there's a lot going on this slide. So the scale factor is the amount that an image is changed by multiplication.
I'm right here.
Lizzie's right there. So if you are enlarging something like by a factor of 3, you're going to multiply the x and the y by 3. Or you can look at this one. How does this one look like it changed? This, oh no. It's because my kids are behaving, right? Something's got to happen. Yeah, right. So how does it look like that, like the triangles are changing? What's happening? Yeah, the triangles are going up by 2. They're being doubled. Yeah, it's exactly what we've done. So now if your scale factor is greater than 1, if the dilation is not a fraction, basically, then it's an enlargement. If you have a scale factor that's a fraction, it's a dilation or a reduction. Okay, so first thing we got to do is get the coordinates of this triangle here. What would we say the coordinates of this triangle are? Go ahead and put them in chat. Right? Yeah. She's just hanging out. Z is 0, 4. I would agree with that there because it's 1, 2, 3, 4. 0, 4. Good. What about X? X is, well, Y is at 2, 0. Yeah, that's Y. What about X? Negative 2, 0. Good. So now we're going to apply an enlargement. Lizzie, stop doing that. We're going to multiply it and see how our scale factor is 3. It's not a fraction. If it was a fraction, you would just divide. But this one is not a fraction, so that tells us we're going to multiply. So we're going to multiply the X and the Y by that 3. So if I multiply 0, 4 by 3, 0 times 3 is 0. 4 times 3 is 12. So 4, 5, 6, 7, 8, 9, 10, 11, 12. It would be up here. That would be Z prime. Okay. You know what, Kenzie? I'm not real sure. If it's a separate mouse than your computer, then you might need a battery. If it takes a battery, otherwise I'm not real sure. Yeah. Yeah, I would use your touch screen just for now, just to get through if you have a touchpad. Unless you're on a desktop. So yeah, just to get through, that's what I would do. That kind of rhymed. Okay. And then 6, 0, yeah, that would be the other ones, right? If you're going to take them and multiply by that scale factor of 3, you would get 6, 0, and then negative 6, 0. So 2, 3, 4, 5, 6. There's Y prime. 3, 4, 5, 6. There's X prime. So this, it is cool. I agree. Would be our enlarged triangle. If that was a 1/3, don't get freaked out by fractions. All you would do is just divide everything by 3. That's it. So to go from our big triangle to our little triangle, we would say it has a scale factor of 1/3. That's how we would get the little triangle. We would divide everything by 3. Any questions on that? Where did my chat go? There it is. Any questions on that? It's pretty straightforward. You're just going to multiply by whatever that scale factor is. Yeah, I would talk to your mom and dad. That's what I would do. Okay. Thanks, Kenzie. Okay, so I'm not going to use polling tools, but here's that 1/3 like I was talking about. Okay, triangle RST is located at these points. Okay, it's dilated with a scale factor of 1/3. So you got to divide everything by 3. Which one of those do you guys think is right? Go ahead and raise your hands. What do you guys think? Which one of those is the correct one? Oh, honey. Okay. I'll be right there. I got a sleeping babe. Can you go ahead? My big girl? I'll get you some. Okay. You're going to be back. Be right back. I saw that. That's very good. All right, Kenzie, what do you think? Which one would it be? What says Kenzie? Kenzie having mouse issues. Oh, she circled. Very good. All right. Kenzie says it's number 2. Toru, you disagree? What do you think it should be? You say number 3. Ooh, okay, let's look at number 3. So the first ones look the same. Let's look at the second ones. The second point is S, 10, 12. We would have to divide both of those by 3. So, yep, that would leave us with 10 thirds. We just leave it as a fraction. And then 4. Good. And then our last one, the only difference is that -6. -6 divided by 3 definitely is -2. Very good. Everybody else get number 3? If we just divide every one of those points by 3, we would get all the points at number 3. What do you think, Frankie, Stella, Kaden, Kenzie, Jana? What do you guys think? Miriam, Toru? Does that make sense? We're just dividing every one of those points by 3. 3 divided by 3 is 1. So that would be our new point, and that's how we dilate. That's how we make a figure smaller. Beth, you say so? Okay, good. Good, good, good. Okay, good. And I'm glad that you can see that. That's okay. That's very, very good. All right. Guess what, guys? That's all I really got for you today. That is, in a nutshell, translations. I know, right? That's it. That's all I got. We're ending on time. What? What? I did it. I did it. Finally. Took week 16, but I finally did it. I did it. Let's focus. It was the baby. Baby power. No, I'm just kidding. Yes, it's actually on Moodle. I finally posted it on Moodle. So if you check out the Moodle week 15, it's on there. Thank you. Have a good day, you guys. Contact me if you need anything.